Starting from this video, we will be using TensorFlow as our primary tool for studying deep learning. TensorFlow is a powerful and also quite mature open source Python library for scalable machine learning. Before we can start programming using TensorFlow, we need to install it on our machines first. The TensorFlow website, which is www.tensorflow as one word .org. So if you go to this particular website, it actually has a quite detailed explanation about. So if you click on the install link, it's gonna give you very detailed instructions about how to install TensorFlow on each of the major operating systems. And for the Linux, this is Ubuntu, right? But it also the installation instructions are also applicable to other flavors of Linux, right? For Linux and Windows operating systems, the installation guides also provide a quite detailed instruction about how to install TensorFlow with GPU support. So if you have a graphic card, right, graphic processing unit, or a GPU installed on your machine, and you can actually use TensorFlow with the GPU support. And these instructions basically tells you how to install the NVIDIA's CUDA toolkit, and then how to make sure that this NVIDIA's CUDA toolkit can work with TensorFlow. And in fact, if you have a GPU, TensorFlow can actually run very quickly, very fast. I am actually on a Mac. I'm on a Mac, and starting from version 1.2, TensorFlow is not supporting GPU on Mac OS X now. So the latest version is actually 1.3, right? It's 1.3. That's the latest version when this video is made. So on this Mac I'm using right now, I only installed the CPU version, right? But on other machines that I have, I was able to install the GPU version. The installation path I took on this particular machine was provided by this link, installing with Anaconda. So I installed Anaconda first, and then I followed the instructions listed here, right? Anaconda is actually so there is a link to the Anaconda download site. So Anaconda is actually a Python package management system. It has an installer. If you just click on the operating system that you are using right now, and then it's gonna automatically start to download a installer for your particular operating system. And on my Mac, all I had to do was to actually download the installer, and then just click on it. Then all the Python development environment is set up for me. But it's not gonna install TensorFlow automatically for me, right? So after I finished installing Anaconda, I still actually have to sort of go back and type all those commands inside of a terminal window. So if you don't know how to open a terminal window on a Mac, all you have to do is to hold down the command key. Hold down the command key without releasing it, and then press the spacebar on your keyboard. Then it's gonna give you the spotlight search, and then all you have to do is to type terminal, and then press enter, and then it's gonna bring you a terminal window, right? And then all I did was to just type up every command inside of this instruction. So first, conda create -n TensorFlow, this conda command is going to be available to you after you have finished installing the Anaconda, right? So once Anaconda is installed, it will automatically comes with these command line tools, including the conda and also pip, right? And also this source. So all the command line tools that's used in these instructions comes with the Anaconda. So after you have finished installing Anaconda, you will be able to actually type up these commands inside of the terminal window. And after you have, I myself didn't actually have any problems. I myself didn't actually run into any problems by executing those commands. Conda create -n, it's just a conda environment named TensorFlow. You just create a new environment variable, and then you can activate that environment. The actual installation is actually done by this particular command, pip install. The only thing that you have to sort of pay attention to is this thing, -- ignore installed, and then -- upgrade TensorFlow. Right? You can either use a URL or just by typing the word TensorFlow, one word, right? One word TensorFlow, just like that. Right? Either case is fine. If you forget about this ignore installed, you may run into some trouble. But if you include this particular option, then it should work out fine. Right? Anaconda is gonna the Anaconda that you installed can be a Python 3.6 or a Python 2.7, right? If I myself actually installed Anaconda that comes with Python 3.6, but if you actually choose to install Anaconda or Python 2.7, you also have a pip or pip, right? And all you have to do is to sort of use this particular URL, right? And then I also tried this path. And it was completely fine with me. I didn't actually have any problems, right? And then after you have finished installing, if you run into any kind of trouble, you can always Google and search the error message produced by the installation process. And most of the time, you can find solutions either on Stack Overflow or the Quora Digest or any kind of other places. It's actually not too difficult to actually solve those problems. And once you have finished the installation process, we can test our installation by just writing just one line of code. So first I import TensorFlow, and then I'm gonna print TensorFlow dot version. These are two underscores basically. That's two underscores. And that's it. And then it's gonna print out the version. It should print out the version of the TensorFlow that you just installed. For my machine, I'm using 1.3.0 actually, so it's the latest version. And one advantage of using Anaconda, is that one advantage of using Anaconda instead of just a purely terminal version installation is that Anaconda actually provides it's going to automatically install the Spider integrated development environment or IDE for us, right? This IDE is actually very convenient for developing Python codes. So once you have finished installing Anaconda, you're gonna have a new application that's called Anaconda Navigator. This particular application, and you can just execute this particular application. and then it's gonna give you this module that's called a Spider. It's actually an integrated development environment that works for Python. It's a very powerful Python IDE, and then you can just click on it to launch this particular IDE. And then once the IDE is launched, we can just go back to close Anaconda Navigator. And now we have a complete development environment for us to actually work with. Right. So you have the editor on the right hand side, and then on the left hand side, you have a panel for displaying variables, for displaying files, the file system for you to navigate through, and then a help. And then down here you have a IPython console in which you can run your Python commands interactively. And here you have, on this side you have the editor, which you can actually write very long Python codes. Now we are inside of this Spider IDE now, right? And we'll do most of our work inside of this editor. So we can blow up the fonts in the editor by holding down the command key and then press the plus sign. And then the font is going to be bigger and easier to see. And for now, the file name, the default file name is going to be untitled0.py. And we can try to save it as, let's save it as a different name. Let's call it hands-on start to TensorFlow. Let's call it 01. Right. Let's save it like that. So now the file name has changed to the one that we just created. So now let's try to write some TensorFlow code, right? And what's going to be our first line of TensorFlow code? Right? Our first line of TensorFlow code is actually to import the TensorFlow library into our own Python program. So import TensorFlow as, let's call it TF. That's like a the TF is sort of used almost exclusively to represent TensorFlow now in Python programs. Of course, you can choose a different shorthand, right? You can call it a T or call it a TFlow or anything that you want to use. But TF is like a sort of de facto sort of shorthand for representing TensorFlow in Python. So that's going to be our first line of code, which is basically just importing the TensorFlow library into our own Python program, right? And we give it a shorthand representation. That's TF, TensorFlow. The basic principle for writing any kind of a TensorFlow code is that we have two phases that we need to complete. In the first phase, we need to write the code that's going to define something that's called a computational graph. It's for defining a computational graph. And in the second phase, we write the code that's going to execute the computational graph, which is defining the first phase. So basically, any kind of a TensorFlow code sort of that we have to write can be actually separated into these two phases. What exactly is a computational graph, right? It's actually a very general representation of any kind of a mathematical calculation. It is actually so general that it can be used to represent mathematical calculations of arbitrary complexity. It doesn't really matter how complex the calculation could be. Could be lots of function calls, could be really complicated functions, could be the entire calculation involved inside of a deep neural network with millions of connections and thousands of nodes, right? It doesn't really matter how complicated this calculation can be. You can always represent it as a computational graph. In fact, the entire TensorFlow library is actually built around this very general concept of the computational graph, right? So now let's look at an example of a computational graph. So suppose we have a very simple mathematical calculation, which is given by this particular equation, right? So f equals to x times y plus 2. To represent this calculation using a computational graph, we need to have two variables, x and y, right? And then we first apply the multiplication operation between x and y. So we have something that's called a node here that represents multiplication, and both x and y goes into this operation, this multiplication operation. And then the result of the multiplication operation, and also a constant 2, which is represented by this red circle here, a small red circle here. Both the result of the multiplication and the constant 2 here are fed into another node, an operation node that's called add or addition. This is addition operation. So in this particular computational graph, everything that's not an edge, these kind of arrows are edges. It points to the direction of the data flow, right? Everything that's not an edge is called a node, right? So this is a node, right? And then this is a node, this is a node, this is a node, and this is a node, right? Everything that's not an edge is just a node, right? And then the nodes x and y are called variables in TensorFlow. And this small node here, the small red node here, that represents the constant number 2, is called a constant in TensorFlow. Those variables, constants, are actually objects in TensorFlow. Actually, they are actually objects. They are full-featured objects. They are not just a very simple container. It's actually a very complicated representation of variables and the constants. And then the two nodes that represents multiplication and addition are called operations, or simply ops in TensorFlow. Again, these operations or ops are full-featured classes, are full-featured objects. Actually, they are not just some arbitrary thing. They are actually a very concrete class or objects that's going to represent those operations. And all those operations can have names. You can actually represent an operation using a particular name inside of TensorFlow. So if we choose to execute any one of those nodes inside of this graph, say if we want to execute the add or addition node, then TensorFlow will automatically execute all the nodes that this add node depends upon, including this mult node and also the two variable nodes, right? It's called a variable, right? But in fact, there are operations involved inside of it, including initialization of those variables. Those are actually operations. So in order to actually sort of come up with these kind of variable representations, you actually need a class to actually define the actions that you need to perform in order to initialize them, and then other operations that can be applied on those variables actually. Right. So basically, TensorFlow is pretty much just a tool for you to actually define computational graphs and to execute computational graphs. If you actually if you want to sort of summarize TensorFlow in just a one sentence, it's basically just a software library for defining and for executing computational graphs. So now let's look at how we can write the code that will define the graph. This is we'll try to write the code that's going to define this particular graph first. Right? That's the first phase of any kind of a TensorFlow code. Right? So let's try to define the two variables first. So x is going to equal to tf dot. So how do we actually define a variable, right? So tf is going to be used to represent TensorFlow, right? And this TensorFlow have something that's called a variable defined on it. And then let's assign the value 3 to the variable x, and then there's a optional second input variable, that's the name of the variable that's going to be used inside of the computational graph to represent this particular node. Right? So this variable is going to have a name that's given by a text x, and then it's going to have a value that's 3. Right? Building the graph. First phase. Right. So in the first phase, we are only building the graph. It's not executed. Right. So if we execute this particular line of code, then it's not going to sort of do any calculations. X is not going to be initialized with the value 3. Right. The initialization is postponed until we actually try to execute the graph. And then y equals to tf dot variable, and then let's give the number 4, and then also a name equals to y. So here we have defined two TensorFlow variables with names that's given by these two strings x and y, and then values is 3 and 4 respectively. Right. But that's not the end of the graph yet. We still need to define the operations, right? So f equals to x times y plus 2. Right. So it looks like that we're actually computing the value for f here, right, on this line, using the variable that's x and y. That's defined here, right? But in fact, this line of code actually does not do any calculation. It is still sort of in the defining the computational graph stage. In fact, if we execute these 3 lines of code, let's try to execute it by clicking here. Let's just execute it, right? So after we have finished, after we click on this button, this run button, and if we go to the variable navigator or variable explorer here, we should be able to see. So TF is the module that we have, is the TensorFlow module that we have just imported. So that doesn't really matter. And then we can see X, Y, and F here. Right? For now, these things probably doesn't make sense to us, but you can sort of see something about it, right? So X and Y have a type that's given by this really long string, ends with variable. And then F ends with tensor, right? And then the value of all 3 objects are actually class, right? Are all classes. They are not really values, actually. So in fact, before executing the graph, these 2 variables, x and y, don't really have values, actually. Don't really have a defined value yet, because they haven't been initialized yet, right? The initialization of all those variable objects will also be postponed until we actually start to execute the graph. And in order to actually execute the graph, now let's write the second stage, right? Executing the graph. Second phase. So in order to actually execute a graph, we need to create a TensorFlow session. By doing this. So here sys is something that's called a TensorFlow session. And then we must use this session to initialize the variables first. So how do we actually initialize the session, right? Initialize the variables. We call the run method defined on the session object, and then this run method is gonna take something that's called a fetch. It's gonna take something take a fetch as its input. So then what's gonna be a fetch for initializing variables, right? X dot initializer. This X dot initializer is gonna return a fetch that can be executed by sys dot run. Right? That's gonna initialize the variable X. Right? It's gonna initialize it with the value that you just provided, and then the name that you assign to that variable. Right? And we must do the same thing for Y. That's sort of the initialization stage. Right? And once those initializations are done, we can use them to evaluate F now. So sys.run actually can return something. That's the result of executing a particular graph. And then this F, this tensor that's defined here, can be used as the input to run. Run is going to execute the node this F is going to represent. And then, because this F node is going to depend upon all those nodes that's below it, right? So the session is going to execute all those nodes that this F node depends upon, and then completely traverse the computational graph and evaluate everything. And the result of this calculation is going to be stored into result. Right? So F itself is not the result of the calculation here. F itself is merely a representation of the entire calculation, and you have to run it to produce an actual result, right? And then we can just print out the result, right? Result is something that should be an integer. And after we have finished all our calculations, we must remember to close the session by calling the close method on the session. Now we have finished both the first phase, which is building the graph, and also the second phase, which is actually executing the graph. And in order to execute the graph, we must use a TensorFlow session. So let's just click on the run and see what's going to happen. So it's going to print out 14, right? So 3 multiplied 4, that's 12, right? 12 plus 2, that's 14. So result is actually a int. It's an integer type, int 32. Actually, in the 32 type, it's going to have a value of 14, right? A slightly different way of executing the graph is actually, let me comment out this block. So I'm going to comment out this block of code, and we'll write a different piece of code that's going to do pretty much the same thing, right? So it's a slightly different way of doing exactly the same thing, which is to use the with construct provided by Python. So with is actually a keyword in Python. It's a keyword in Python. With what? With ts.session as, and then x.initializer.run. y dot initializer dot run. Then result equals to s dot eval, and then print result. So what exactly is this undefined variable? So the editor, the ID is actually telling me something is wrong here. It's not TS, it's TF. There's a typo here, right? So now if I make the correction, then that warning disappeared. If I execute this piece of code, I'm still getting 14. The result is actually exactly the same. There's no difference. There's no difference. So this piece of code is actually equivalent to this piece of code, right? And the only thing that's different here is that sys.close is missing, right? We are not doing sys.close. So this with construct in Python is going to ensure that all the resources that you have opened behind this with statement are going to be closed automatically when it reaches the end of this with block, right? So by the end of this particular line, which means what? Which means this block underneath with has finished, right? So the scope of this width has actually closed. When the code actually runs to this position, it's going to automatically close all the resources that's open here, right? So if you have used a recent version of Java, you probably noticed that this with construct in Python is somehow similar to the try with the resources statement introduced in Java 7, right? And the try with the resources statement in Java also ensures that every resource, in our case, it's just the TensorFlow session here, right? The TensorFlow session here. Every resource is closed at the end of the block, right? So this is just another way of executing all those initialization and evaluation, right? So in this block of code, all those evaluations were carried out by using sys.run, this method, right? The initialization was carried out by sys.run. But here it's by calling the run method defined on the initializer, which is actually a component or actually a member of the variable object, right? And then the evaluation of the F node, the topmost node, was carried out by using the eval method defined on the tensor, right? The tensor object. And then the result of the eval is being assigned to a result. Right? And here it's still using sys.run to evaluate f, right? But here it's basically just using a .eval method on f, defined on f. So that's sort of the differences, right? So that's sort of a second way. That's the second way of doing the same thing. Right? If we have lots of variables, initializing each one of them by hand like that is going to be quite tedious. We can insert another operation node into the graph before the execution phase, basically. And when executed, this node will actually ensure all variables will be initialized. And this initialization node, let's insert the initialization node before the execution. Before the execution. So this is still inside of the first phase, building the graph. This is before the initialization phase, executing phase. So let's define a init operation. tf.global variables global variables initializer. So init is going to be a TensorFlow operation. An operation is also one kind of node, right? It's also one kind. So here we are actually inserting a node into the computational graph by calling this global variables initializer function that's defined on the TF module, TensorFlow module, right? And this is just defining the graph, right? But here we can actually comment out these two lines now. We can comment out these two lines and replace these two lines with just one line, which is executing this particular node, called init.run, right? And again, this is just a run method defined on the init operational object, right? And we can still run it. The result is still the same, right? But now in the variable explorer, we are supposed to have another object now that's called init, right? That's another node that we inserted into the graph, and it's got a type that's operation. See? So for all the nodes that's inside of your computational graph, it's either an operation or a variable, right, or a tensor, right? So so that's basically three different ways for executing a graph.